What's going on, guys? Welcome back to Classic Octane. I am Taylor. So right off the bat, this video is going to be extremely in the weeds, very technical kind of shop infrastructure video. If that's not your kind of thing, don't worry. We'll be back to working on cars and bikes and all that kind of stuff very shortly. So I am waiting on parts for the R65 project. So I wanted to go ahead and knock out another project in the shop that I do have the parts for. And what that's going to be is wiring my do-all bandsaw with what is known as a variable frequency drive. So before I get started, I am not an electrical engineer, so take everything I say with a grain of salt. I taught myself all of this off of Google searches, but presumably, if you guys are watching this video, whatever we do works. So before we get started on the bandsaw, I want to give you guys a very high-level rundown on the differences between a single-phase and a three-phase motor, as well as go over a couple of the different options I had to choose from to power the three-phase motor that's in our bandsaw. So single phase is what you're going to find in pretty much all like residential tools in the US. None of us, for the most part, have three-phase power coming into our house. Almost exclusively in the US and residential, it's going to be single phase, 240 volt, 60 hertz. That's what we have to play with, so to speak. So my air compressor, my belt sander, chop saws, all that kind of stuff is all single phase motors. Where we get into three-phase is big industrial equipment. So that's my bandsaw, the mill is three-phase, my lathe is three-phase, and there's some kind of pros and cons of each. So for single-phase, the biggest pro is price. It's just generally cheaper to manufacture a single-phase motor. That's kind of where the pros end for that. Where you get into the pros for a three-phase is they are way more efficient. They are also much smoother and quieter, and typically the motors are actually smaller than the equivalent horsepower single phase. So if you want to think of it in terms of combustion engines, a single phase is kind of like a single cylinder engine. So it's going to have that, up and down kind of single, stroke, power stroke, if you want to think of it that way, per revolution, where a three-phase motor is kind of like a radial three-cylinder engine with a piston at every 120 degrees. So if you have three kind of sources of power, so to speak, you can see how that can be way more efficient, way smoother operating. What that also allows us to do is have way more control over the torque output at lower RPMs, which is mainly important for machines like this. If you're low RPM and you're hogging out a whole bunch of metal, you don't want to lose too much torque because you can stall the motor that way. So that is an extremely high level kind of view of the differences between the two, but that is why all of your big industrial equipment is going to have three-phase power. And really that's ideal for us because we have little things like this that will allow us to run it off of single phase, but still have all of those benefits. So now I want to quickly go through the three main options I had to choose from to power our three-phase motor off of single phase power. So the first one is what's called a static phase converter. It's actually what I'm running on the mill, mainly because it came with the mill when I bought it. And if it's not broke, don't fix it. It's not what I would choose to run today, but it was already there. So a static phase converter will just convert single phase to three phase. All the voltage stays the same, the frequency stays the same, all of that is just kind of static. And then you get three-phase power and you just use the machine to adjust your RPMs. So I have like a 2-speed motor as well as a ton of belts and pulleys to adjust the RPMs. So all of that is just kind of run as God intended with the machine itself. The next solution is what's called a rotary phase converter. It is probably the best overall solution, but it's very expensive, one. And two, a rotary phase converter is for somebody who wants to run a multitude of different machines and also run basically a full three-phase circuits throughout their shop. So where you just have a bunch of outlets on the wall that are just three-phase power, just as if it was coming from the power company. It uses a big industrial motor to kind of spin another generator, and I don't even know how it all works, but it basically outputs three-phase power that you run through a breaker box and all around your shop. That is probably the solution I will go with when we build the big shop. I didn't want to go with that level of integration into my house, just because I don't know how much longer I'm going to be in this shop before we build the big one. So the third and final option is what I went with, which is what's called a variable frequency drive. So a variable frequency drive, similar to a static phase converter where Single phase power comes in, 3-phase power comes out. But where they differ is the amount of kind of programming and customization you can do with one of these. So let me talk through some of those options. So I told you guys this was going to be a technical one. I hope you're still with me. So there's a couple of features of the variable frequency drive that kind of led me towards choosing it for this particular application. So I want to touch on those really quick. The main one is going to be our almost infinite adjustability of the speed of our motor. So that's what the variable frequency means in VFD. And what that means is, say the motor is designed to run 60 hertz, and that is 2,000 RPMs, just to make our math easy. If we run that same motor at 120 hertz, we'll get 4,000 RPMs out of it. If we run it at only 30 hertz, we'll get 1,000 RPMs out of it. So you can see we can adjust that frequency to increase or decrease the speed of the motor itself. Why that matters for a machine like this is because if you see this big dial up here, this is all of the ideal cutting speeds for different materials. They're all rated in surface feet per minute of the blade itself. So for example, 4140 steel, 240 feet per minute. Aluminum is going to be faster. Things like cast iron, stuff like that, is going to be a little bit slower. It all varies. So we needed that functionality to be able to go in and change it. This machine does have the ability to change blade speed manually. It's actually a mechanical wheel. I don't know if you can see it over there on the left-hand side. It's a big wheel you crank, and it is basically just adjusting this huge pulley to change our belt speed. I wanted to go a little bit kind of fancier than that and do it all from this tiny dial. We could even get as far as having a bunch of pre-programmed buttons on here where I can hit, a button that's steel, and it's going to go to our ideal speed for cutting steel. Another one for aluminum, another one for brass, whatever materials I cut most often. I probably won't do that, but that's something you could do with a converter like this. We can also adjust and control our start and stop speeds. Why that matters, for start speeds, I can set it to kind of ramp up over a couple of seconds to our desired RPMs. If you think about a static phase converter like I have on the mill, it is all the power all at once. It's an on-off switch and that is it. So it's going to shock that motor all the way to full RPMs instantly. And that can just kind of be a little bit more wear and tear, be a little bit more rough on the motors itself. Those motors typically last a good amount of time, so I don't know how much more life we're going to get out of it by being a little bit more gentle, but I kind of like the idea if it's a 10.5-foot metal blade with some giant wheels and stuff, just slowly getting everything up to speed is completely fine with me. I'm not in that much of a rush. The more exciting thing than that is the braking features as well. So I can program in how long I want the motor to take to come to a complete stop. I can also program in an emergency stop. So I can have a huge red button, I can hit it and it will stop that motor almost instantly, which is really nice if you had a piece of material get wedged or something like that and you need to stop this thing in a hurry. It's nice to have a big emergency stop. Typically when you turn it off, I'm going to have it just over a couple of seconds kind of taper off and slow itself down. That's nice for a machine like this because this does not have any sort of mechanical brake to slow things down. The mill, if you turn the mill off, especially if you have a good weight cutter in there, if you don't touch the brake on that thing, it'll free spin for a minute, maybe more. That's why you have to use the brake to slow that thing down. This will use the motor to slow the machine down and stop it. So that is just like the very high level benefits of a variable frequency drive. There is a ton more functionality we could get into, but that's mainly what I care about for this application. So I pulled the back cover of this thing off so I can show you guys how the factory did the speed adjustment. So this is that crank wheel I was talking about. You crank this wheel and what that does is basically adjust where this center pulley is. That pulley kind of varies in thickness, so the belt kind of either goes in or out of the pulley, and that's what adjusts the ratio and it changes your RPMs. So the motor is down at the bottom that runs that center pulley, and then there's the belt that goes in that kind of variable section up to the drive wheel that actually spins our blade itself. So that is all going to be set to kind of right in the mid-range. I got to figure out where that is because like I mentioned, we're going to use the variable frequency drive to do all of that adjustment. So I just want to get, mechanically us right in that kind of middle RPM range, and then we'll just do all of the future control through that VFD. One thing I didn't mention yet is the actual size of the VFD is rated in horsepower. And what you want to do is just get a VFD that is rated for twice the horsepower of your motor. So on my little motor plate, I can see that this is a 1.5 horsepower motor. So the VFD I got is rated for 3 horsepower. This little device over here is actually just a small air compressor that is also run off the motor. What that does is it runs up through the machine, and there would typically be a little hose right here that would come down and just kind of blow the chips away. I'm probably going to just skip that whole setup completely at the moment. We'll see if chip control or something ends up being an issue. I don't think I'm going to be running through enough parts to kind of justify getting all that up and running. I imagine all of that hose and everything all would need to be replaced, so I'm not going to worry about that. What I do need to get is another one of these belts. So this is a belt that runs from our kind of drive pulley over to this little pulley right here. And what this is a speedometer of sorts that will show us our surface feet per minute of the blade itself. So you can see it goes all the way from 50 feet per minute to 5,200 feet per minute. So I went ahead and hooked everything up temporarily just to test it and to kind of show you guys how it's all wired before everything is nice and hidden. So as of right now, I have the wire just coming straight out of the wall and into the VFD. For my permanent install, I am going to utilize this heavy duty switch that's on the side. So my power will come straight through here, 1, 2, 3 legs, and then I'll trace those wires that come down, and they come into this box that did have the original kind of motor controller in it. That's where it will be connected to the VFD. Right now, it just runs straight in. So we have the 3 connections on the left-hand side. Then what we want is to find the wires that go straight to the motor. So we're completely bypassing all of the factory kind of setup right here. This is the conduit that runs straight down to our electric motor. You can see it on this side right here. So there are 3 wires that come out of that motor. And on the factory controller, they are labeled T1, T2, and T3. So I found a diagram online that associates those with the letters that are on the VFD. So it's T1 goes to U, T2 goes to the V, T3 goes to the W input. So 1, 2, 3, U, V, W, just right in order, pretty simple. And that's it for our main wiring connections. So when I do this permanently, I will probably hook the VFD up on the back of the machine just so it's kind of out of the way. And then this little control panel actually comes off and you can relocate it anywhere you want. We're going to relocate it into the panel that goes right here. So it'll just be a nice clean little display on there. But I'm going to go ahead and show you guys it operating now. I have already tested it. The belt on the motor to this kind of variable pulley is kind of permanently dried into a bit of an oval shape. So it creates a bit of vibration. I am going to go ahead and order some new belts as well, but I'll go ahead and show you. We'll just start it right on this full 60 hertz. So everything is running as it should. Obviously I don't have a blade or anything installed because we're just testing. So as of right now, I can use the factory speed control if I crank this wheel. That's changing that pulley. I don't know if you can see it in there. So that slows everything down. That knocking is from our belt being a little bit off. So you can see how slow we can get this thing. And that's at the factory 60 hertz. So I'm going to crank it up a little bit. We'll just crank it somewhere in the middle there, and I'll show you that I can do the speed control through the VFD. So we're at 60 hertz. I can bump it down to, say 45. don't know if you can hear that it's slowed down. I can go slower. We can go down to 30 if we want. It really starts to show off our misshapen belt. But you can see how slow it is. And we can go the other way, so I can crank it up. Right now the default setting is a maximum of 65 Hertz. So that's it. We have two different ways to control our motor. I hit the red stop button. That ramps the Hertz all the way down. Comes to a stop. So I haven't programmed in any faster braking than that. That's this what it is, the factory default setting for the braking. I can have it stop much quicker than that if I want to, but I'm gonna wait until I have the blade and everything kind of final install before I worry about those settings, just so I can see how it's gonna stop in its final form, so to speak. So I hope all of this makes sense, but it's all operating exactly as I hoped it would. So what I'm gonna work on now is just the final install, make everything pretty, get all our panels and everything mounted properly, and then I can bring you guys back when we have a blade and everything installed, and you can kind of see it operating in its final form. And just like that, she's all hooked up. So you can see the control panel is nice and flush mounted right here. This is also where I'll probably install that big emergency stop button I was talking about. We'll worry about that at a later date. I'll probably eventually remove this control box as well, because it's completely useless now. It doesn't actually do anything, and it's kind of in the way of me seeing our blade speed, kind of a speedometer, so to speak, down here. I have to kind of, you know, bend over to look down to check the speed of everything, but we'll worry about that later. I do have our brand new 10 tooth per inch blade installed as well. All the blade guides and everything seem to be in really good shape, so we don't have to worry about that. I went with the 10 tooth per inch because looking at our chart, most of what I'm gonna cut, that's what it recommended. So like most of our mild steel and everything is all 10 pitch. I also bought a 14 tooth blade as well, should we wanna do that. These saw blades were surprisingly inexpensive. I went through, what was it called, sawblades.com, I think. They were like 20 bucks a piece, so I went ahead and got two of them just so we have some spares. Nothing else changed back here since you guys saw me last. This is where the VFD box is mounted itself. Power comes through our main switch, as I mentioned. I did go ahead and order all 3 new belts direct from Do-All. So we'll have a new drive belt, new variable speed belt, as well as the belt for that blade speed indicator as well. Those are all on the way, so we'll have to swap those out later. But let's go ahead and fire this thing up. So we can flip our main power on. Turns on the VFD, and then yeah, we'll just start it at a 60 Hertz. I bet this thing will quiet down and smooth out quite a bit with those new belts. Throw my safety glasses on. We're making chips, people. One thing I wanted to mention quickly is the blade welder. I did not wire this up. None of this is functional at all because I just can't really envision a time where I'm going to use the blade welder. What that's designed for is if you're cutting the center out of a large part, you can take your blade off, bring it over here, cut it in half, thread it through your part, re-weld it back together, put it back on the machine, and be able to cut the inside of something. I can't imagine me doing that. So I don't know. I don't think it's really worth me wiring it all up. Should I decide to wire it up in the future, it is actually single phase. You can actually probably read it right there on this little tag. 240 volts single phase. So I could really just tee right off of our main power source that comes in and just power the blade welder right off of that. We don't even have to run through the VFD. But again, I don't really foresee me using that, so I didn't bother hooking it up. Well, that's where I'm going to call it on this extremely technical video. If you guys made it all the way this far, you're either really into old machines or just a diehard fan. Either way, I greatly appreciate it. Little thing for you guys, I just bought something at auction like 2 hours ago that I am incredibly excited about. It is going to be a new project, long-term thing for the channel that's going to allow us to do a ton of different events and all kinds. I'm just really excited about it. You guys will see what that is in the not too distant future. So I appreciate you guys watching as always, and I'll see you on the next one.